YouTubers are misleading you about VPNs. I was going to slot in a bunch of clips here of YouTubers, some in China shilling their VPN, which claims to give access to the World Wide Web. It doesn't often, and it's notoriously unreliable. I can confirm that. And then there's others who are employing scare tactics, saying that your password and your financial information are going to be vulnerable. As soon as you get out of your mother's basement, you log onto the Wi-Fi of a cafe or an airport or the library, and some hacker is going to compromise you. So I thought about putting all these clips in, but when it came to it, I realized that these YouTubers, I wanted to give them the benefit of the doubt. They don't work in IT security, and they're not cybersecurity analysts, they're not software engineers, but they've done a deal with a VPN provider. I don't condone that. I think you should also always know the product that you're shilling, so to speak. But they just don't fully understand how the VPNs work. So what I thought I would rather do is just do a tutorial, which we're going to get into in a moment. But first, let's talk about fallacies. Is that, there's two things. One thing is that if you don't use a VPN, you're not going to be secure. And the other one is if you use a VPN, you're going to be more private. Now, it's not necessarily true. Some VPNs, they do try to be more anonymous. For example, Malvad and Obscura VPN, they let you sign up without an email. They let you pay with a cryptocurrency like Monero, and that's an anonymous private cryptocurrency. And as such, it's hard, if not impossible, to tie your identity to the service. And then other VPN providers, what they do is they say, we have a no log policy, we've been audited, and we don't log your metadata. Now, often people will say, well, they're logging the domain. There's actually more to it than that. But what are we even talking about with respect to what are these metadata, right? What they mean is in modern browsers and apps, they all use secure encrypted tunnels, right? So the little lock in your browser stands for secure. So Hypertext Transfer Protocol, secure. That's S is for the secure aspect of it. And so all modern Android apps and iOS apps and also web browsers like Firefox and Chrome and Brave, they're all encrypted. And so it means that the data that's exchanged with the websites is already encrypted end to end. A VPN or your internet service provider, it doesn't magically make your connection private in airports and hotels and that kind of thing. They still, however, see some metadata. So they can't actually see the encrypted traffic, which is being sent to and from. But they can see a few things. They can see how often you visit the site. They can see how much data is exchanged. They can see your operating system and browser and the transport layer fingerprint, right? And then, most importantly, they can see the domain name that you're visiting. So they can't actually see the sub URL. They can just see that you're visiting youtube.com or whatever it may be. And so they are able to log that. So VPNs do prevent, on the one hand, your internet service provider from logging this metadata, but you're robbing Peter to pay Paul, right? Because now your metadata is being logged with the VPN provider. And so the question is, are VPN providers any more trustworthy than internet service providers? That's for you to decide, right? But we can't confidently say that they are. There are many cases where VPN providers and internet service providers have been subpoenaed and by authorities, and they've complied and they've provided the logs that could tie a user to their service. Okay, so does this mean that VPNs are entirely useless and fake? No, it doesn't, because the main reason that we actually use a VPN, the most legitimate purpose and the one that it is most suited to and that it fulfills in its purpose is that you want to present yourself in a different location than you actually are. So this might be to consume the latest Hollywood slop. I don't do that. But let's say you wanted to, it's not available in your region, it's available in the US. You might have a VPN that gives you access or presents you as being located in the United States, right? In my case, my employer might expect me to be working from home, and yet I want to head over to Argentina in a month. And so I want to present myself when working from this location, and so that, all my logins and all that kind of thing are coming from a certain location where in fact I'm not even there. And a lot of enterprise grade Security, if you work in a company, they're probably going to have their own VPN. The real crux of using a VPN is just to this location, that you want to pretend that you're in a different location. You want to route traffic as though you're physically in that location. Now, all of these YouTubers, going back to the start of this video, I'm talking about, they want to sell you a service, and that VPN claims to do all these things. You don't even need to pay for this, because you can actually do it yourself. And what we're going to be doing in this video is, you don't need to pay for a third-party VPN. You can make your own VPN, and you can still get most of the benefit, or all of the benefit, that people get from using VPNs. And specifically, as we've discussed, that is remote access and location routing. So I'm going to be using an old gaming laptop. You can see it here. It's actually a pretty powerful machine, but you don't need a powerful machine to do this. And in fact, if you don't have an old PC, you are welcome to go ahead and use like an AWS or Linode, DigitalOcean. You can use one of these cloud providers, and you can get a tiny virtual server. It'll only cost you a few dollars a month, and often there's an introductory deal, and it'll be free for a certain period of time. You certainly don't need a powerful piece of hardware. And the good thing about going with a cloud provider, although this tutorial is going to be done on this gaming laptop as a server, but it doesn't really matter. It's the same thing. But the good thing about using a cloud provider is you can just pick the service in whichever location that you want. As it turns out, I have my own apartment, and I want to present myself as being here. Right, so broadly, the tutorial is going to cover Fedora has been installed on this machine, which is a fantastic distro for servers. But if you're using Ubuntu or whatever flavor of Linux that you like for your servers, go ahead and do that. I'll include the major commands for the most common distributions like Ubuntu, and we're going to have Fedora, right? And then we're going to set up a Telegram bot, because I won't have a static IP, and we want to notify ourselves whenever the external IP changes. And then finally, we're going to be setting up Wireguard. By the end of this tutorial, you're going to have your own VPN that's actually yours. So there's no logs, full control, and you will learn a ton. Let's get into it. Okay, so in front of you is the laptop. This is an old gaming laptop that I had, and it's a pretty powerful machine. I've installed Fedora. Now go ahead and install whatever you'd like, Ubuntu, Arch, Fedora. I'll keep the commands. The important thing is to note in this section, I've run the command, and you can just see it over here. If I zoom in a little bit. So the command up here is ipaddr show, and we can see down here that this device has a local IP. Now, if you're working on a cloud instance from AWS or something like that, then you're going to be given the IP address of your Linux box. But if you're like me and you're using a laptop, I'm going to be using the local IP of this machine. I'm going to be working on the local network, SSHing in locally. Later, what I will need you to do is I'll need you to go ahead, and if you're using a laptop, you're going to need to go to your router settings, and you're going to have to port forward to the SSH port and also to the Wireguard port. So I'll put on the screen there how I did it. It's difficult to kind of demonstrate for everyone because every router interface and the GUI is slightly different, but it's important to note that later, when we're SSHing in from outside of our local network, or we are using our VPN from outside our local network, we are going to need to have that router port forwarding. Now, if you're working on the cloud and you've rented a Linux box, VPS, you don't need to worry about this step. This is just something I have to note. Okay, so once you've installed your Linux distribution, then let's head back over and let's SSH in. One of the cool things about using a laptop as a server is that you've got a keyboard and you've got a monitor. You can actually just directly work on it. But ordinarily with servers, you wouldn't work directly on the server. And of course, if you're following along and you're using a cloud service, then you need to SSH in. Now, just then when we installed, we created a user. That was my user, Rad. And so you've got your own user and password. What you can do is you can SSH, and you can use the IP address that we obtained there with that command just a moment ago on the target machine. So I can log in like this, and you'll see that it's going to ask us, because it's the first time, you can say yes, and it's going to ask us for the password, right? So put the password in, we're logged in. Great. But it's not good to use a clear text password when it comes to using your server. And what we really want to do is we want to use an SSH key. So what I'm going to rather do, I'm going to say exit, and we're back on my main machine right now. I've already done this, but just to help you out. So the command is SSH keygen, and the type is ed25519. We're going to associate this with my email. So just put your email in there. Okay, now once you've run this command, you're going to generate keys, all right? So you can see your keys on your local system. So I'm the client, I'm trying to access the server, right? So I can look into .ssh, and in here we can see that we've got a public key. So I've got an ed25519.pub. Now, don't show anyone the private key, of course. We want to put the public key so that we can place that onto the target machine. And therefore, when we're authenticating ourselves, we can actually log in. So let's go ahead, and what we're going to do, we're going to run this command. So the command is ssh-copy-id, and then I'm providing it the path of that key that I just generated. Although if you're doing this the first time, it's probably just going to select that public key. And then in here, what I've got to do is I've got to provide the username that we just had, and then also the IP address that we obtained from the target server that we're working on, okay? So I'm going to run this command. Now it's going to ask us for the password. All right, and so now what it's doing is it's saying, try to log in with the SSH key. Okay, and so we did SSH, and then the user, and then the IP address. We logged in, and we can see this time we weren't prompted for a password. The reason being is that we have actually already set our SSH key. So things are looking pretty good. First of all, before we do anything, let's install, I'm going to install NeoVim, which is my preferred editor, but I'm going to first update. Okay, so our system is fully up to date. Now what I'm going to do is I'm going to install my preferred text editor. In my case, I like to use NeoVim, but you can use whatever you like. Sudo dnf install NeoVim. Okay, and now what I'm going to do is I'm just going to edit the SSH config, all right? So we want to make sure that we can't log in with passwords. We've set up our SSH key, and we just want to be extra strict. I'm going to say sudo and then nvim and then etc ssh config. All right, and in here we can search using / and I'm going to say password. As we discussed before, it's a bad idea to have the tunneled clear text password. So password authentication, we're going to say no. Under permit root login, I'm going to say no, and then here, so we've basically turned off password authentication, and we're not having root login. Of course, we haven't enabled root user. So let's now exit, and I'm going to say sudo systemctl restart sshd. We've now set it up so that we're ready to start working on our system. Okay, the first thing that we're going to need to do if we're setting up a VPN is we need to know where the server is that we're going to be using for the VPN. Now, we could do something like, we could say curl, and then we want IPv4, right? So we're going to say -4, and the command I'm going to use fss, and I'm going to set a max time to 5 seconds. But the important part here is we just want to hit one of these sites, which is one of these APIs, which is an endpoint which is going to tell us what our config is. So this one here, for example, so we're going to curl, we're going to send a request. We want the IPv4 address. So the F is just to say fail silently, the S is for silent, and then the final large S is to show the errors. So what we're going to do, we're going to run this command, and you're going to see the IP address. You should see your IPv4. Now, obviously, we're running out of IPv4 addresses, but I'm using that in this case. So obviously, for my own privacy, I'm going to block that, but it's going to be something like, 52.68.3.162 or something like that. So once you've obtained this, what we want to do is we want to always be informed of it. So what I really want to do is say on a daily basis, I want to run a cron job, and that means that I want to run a scheduled job to go out, get my IP address, which is changeable because some ISPs, some internet service providers will allow you to have a static IP, but they might charge you for it. And so in our case, we don't really need a static IP. Rather, I just want to say get my dynamic IP address, which changes every so often, and I just want to be informed if it's changed, right? So what I'm rather going to do is I'm going to create a script. And so what I'm going to do, I'm going to echo last command into, and here let's just create a script. We're going to call it ipchecker.sh, right? And so let's have a look into that file. Okay, so here we've just put in the command that we just ran earlier. What I want to do though is, because we're going to be running this as a system script, I'm going to put a shebang at the start. So we're going to say this pound sign or this hash symbol and then an exclamation mark. And then I'm going to say USR, Universal System Resources bin, and then N. And the program that we're going to use to run this script with is going to be bash. So all the shebang is doing, what is referred to as shebang up the top, is it's just saying this is to tell the system when we run it how to run this specific file. Okay, so now what we're going to say is every time this runs, we're going to say latest IP is equal to this, the result of this curl command, right? We've got the latest IP and we've assigned that to this variable. Now what I want to do though is I want to actually inform myself using Telegram. So I want to send a message from my server to my Telegram on my phone, which with the IP address. Now, of course, we could optimize this to only send a message if it's changed. You could do that in your own time. But in this example, what I'm going to do is I'm actually just going to create a message. I'm going to send it to my phone so that every time we run this cron job, we know what the IP address is of the server. Okay, so what I'm going to do is we're going to send a message, right? So let's assign some information in this Telegram message. So I'm going to say the current IP is, right? And then we're going to reference the latest underscore IP. And let's go and test our script. So let's write and close. We're going to make this ipchecker.sh. So I'm going to say chmod and we're going to say +x to make it executable. And I'm going to say ipchecker. All right, so now I can invoke the IP checker like this. Oh, and we need to do one more thing. Let's go into our IP checker and let's echo message to see the contents of our message. So let's run that one more time. Okay, so the current IP is this IP. So that's looking pretty good. So now what we're going to do is we need to get that message here, which we're logging to the screen. We want to send it to our Telegram chat. All right. Okay, so in front of you, what you've got is a command using curl. We're going to send a post request to the Telegram API endpoint, right? And in a moment, we're going to obtain the Telegram bot token. We're going to need that, and also the Telegram ID, chat ID. So these two here. So let's grab these. This is obviously not going to work until that's done. So let's say Telegram bot token, and we'll get that in a moment. And then the other one is the Telegram chat ID. So we're going to get these both in a moment. And of course, we're also going to pass in the message. So you're going to receive this message that we've got up here in your Telegram chat. Okay, so let's go and let's log into Telegram and obtain the Telegram bot token and the chat ID so that we can run this script. Okay, so what you want to do is you want to go to your Telegram and you want to start a chat with Botfather, right? You're going to see there's tons of users here. And here what I'm going to do is there's actually a bunch of commands, but the one that we want is new bot. And so we're going to create a new bot, and we're just going to call this, say, like server IP checker the rad lectures. Just, you can call it obviously whatever you like. All right, and so we're going to just make sure that we've got the username. So rad lectures bot. So it's got to end in the underscore there. All right, so we've created a new bot and we've got this access token, right? So obviously, I'm going to delete this after the fact, but we need to keep this secure. Okay, so we go back and we search for the name of the bot that we just created, all right? So I've gone out of the bot, exit the Botfather, go to the search, and then search for the name of the bot that you just created. So prefix that with an @ symbol, and then you'll see that in the global search, this comes up. Now, what you can do is we can start. Okay, so once you've started your bot, make sure that token that you will have taken note of, or you can go back and grab it. Grab the token. All right, now we're going to go back to the terminal. Okay, so now we're back in the terminal, and what we're going to do, just make sure that you send your bot a message. All right, I had to send my bot a message in order to get it to send me back any useful information. And so what we're going to do is we're going to curl. We're going to send a message to the Telegram API endpoint. So that's api.telegram.org / and then bot, and then the token that we generated before using the Botfather. I'm just going to pipe that into JQ to make it a little bit prettier. So what I'm going to do, I'm going to copy this chat ID. All right, and I'm going to go to the IP checker script. And in here, what I'm going to do, I'm going to actually just paste the chat ID. Now we still need to put in that Telegram bot token. Okay, so now we have put in our bot token, and we've also put in the chat ID that we obtained just now. So what I'm going to do, I'm actually just going to run this script. Okay, so here I've got my chat, and you can see on my phone here. And then what we're going to do is we're going to run the script, and we should see a message saying what our IP is. So let's go ahead and we're going to run it. Okay, and so we get a message saying this is the current IP. All right. Okay, so our script works. It tells us our IP address, and it sends it to our Telegram chat, and that is pretty cool. But there's a chicken and egg situation here, because if the IP changes, then we won't be able to SSH into our Linux server on the new IP in order to send ourselves a message with the new IP. So we need to have a scheduled job, and that job's going to run on a periodic basis that you define, and this will overcome that. So when the IP changes, in my case, I'm going to set it to 6 a.m. every morning, and it's going to send a message to my Telegram with the current IP address. All right, so how do we do that? It's pretty simple. Before we do it, I'm just going to shift our script. So if you have a look at where you are at the moment, if you ls, I've been working from the home directory, and we've got our IP checker.sh script. Now, ordinarily, we want to actually put executable programs into our system's path. Our path is just where the system knows to look for executable binaries and programs and that kind of thing. And so what I'm going to do, I'm actually going to move our IP checker, and I'm going to put it into US R and then local and then bin. And we're going to keep it called IP checker. If we use the which utility and we look for IP checker.sh, it'll now show the location. So it knows where to look for it. And if we just run IP checker, I've actually revoked my token, and so it's no longer working, but it does run that script, okay? So now the script is in the path, and what I want to do next is I want to put the script into a cron job, or I want to declare a certain cron job, a scheduled job for this script to be run. So what I'm going to do, I'm going to run the command cron tab-e. Okay, and in here, what it is just a file where we get to declare our cron jobs. Now, what you could do is you could say something like @daily, and then you could put in the location. Now, even though we did have a look at the path just now, in order to get this to work, because cron jobs work in a different context, I had to put in the complete path. But here, if we had a cron job declared or defined like this, then it would be run daily. But I like to be a little bit more clear. I want to know exactly what time it would be done. So I'm going to actually run it at 6 a.m. So we're going to say it actually works backwards. So 0 minutes at 6 a.m. And then we're going to have 3 asterisks because we want to run it every day. Okay. If we write and close this, it's going to update automatically. So we don't need to restart the cron service. And as you can see, it's just said that it's backed up my cron jobs. That's totally fine. All right, team, great work. We're really getting close to the pointy end of this tutorial. Specifically, we're now going to install Wireguard. Now, just a little bit about Wireguard. It is, or it markets itself as a fast, modern, secure VPN tunnel. Now, the really cool thing about Wireguard is that unlike some of the other options out there on the market, it's actually pretty easy to set up, and it's also super performant. So here, as it states, it's simple to use, and we're going to go through that in a moment, but it's also very secure, minimal attack surface. It has no logs by default, and there's a bit of information here. What it does is it actually sets up a simple network interface. So for example, if we run IP-addr, then we can see that we've got our loopback, and then we've got some Ethernet, and here the Wi-Fi is down on this machine. I've turned it off because I'm going to be using an Ethernet connection. So the beautiful thing is that the way that Wireguard works is we actually attach it here as a network interface, and that'll make a bit more sense once we've set it all up. Now let's head over to installation. In a moment, we're going to get to the client. When it comes to the server, if you're using Ubuntu, you've got the command here, like I am, for run this command. So I'm going to say sudo dnf and then install Wireguard tools. Okay, so once it's installed, what we're going to do is we're going to generate a private key. You can think of this conceptually in the way that you do SSH. You've got a private key, and obviously the user, so the one who actually wants to manage this process, holds onto that private key. So in the case of SSH, it's on our local machine, and then we give the public key to the server. And so we can use this in the same way with Wireguard. However, the commands are a little bit different. We're going to use Wireguard to generate a private key. Okay, and so how do we generate the private key? Well, we use WG, so that stands for Wireguard. So if you want to see where Wireguard's installed, we just installed it. So we're going to invoke Wireguard, and then we're going to say gen key, right? And we're going to pipe this, or we're going to put into a file. We can call it whatever we like. In this case, I'll just say call it private. All right, now, if we have a look at this file, it's giving us a warning here. In fact, if we say ls and then private key, we can see that it's readable globally by other users. So what we're going to do is we're just going to chmod 600, which means just I am able to read and write. And then I'm going to set the other permissions for groups and other users to nothing. And then what we're going to do is we're just going to reference the file again. And if we have a look at that file again, we can now see it's just readable and writable by us. All right, so we've generated our private key, but now what we need to do is we need to generate our public key. The way that we do this is we use another Wireguard command, so WG, and here we're going to say pub key, And now we're going to reference, or we're going to get the contents of that private key file. Okay, and now it gives us a public key. So to be absolutely transparent is important. You've obviously got to keep this private key secure. I'm going to delete mine after the fact, but this public key is what you share with your client. Now, I'm actually working remotely from the machine that I'm going to use as the client, but this terminal that you see on the right-hand side, this is in the server, okay? So we're going to use that public key, but before we proceed any further, we'll just also have a look at the private key. All right, so this is our private key. The second item is the private key. The top one is the public key. Once you've obtained these, what we need to do is we need to go and set up a conf file for our network interface. Now, I mentioned a moment ago, we're going to be adding a network interface to our machine. So how do we do that? Okay, so what we need to do, let's cat out that private key, and we're going to create the network interface. Now, the location of this is we're going to use sudo because we need to escalate privileges to edit the file. And I'm going to use nvim as my editor. The file is located etc and then Wireguard, and then the name of our service. So I'm going to call it wg for Wireguard 0. The documentation, this is straight out of the docs, so I'm doing that. Go ahead and create this file, and then we're going to go in and then I'll show you what your file needs to look like. Okay, so I'm inside that file. We can see down the bottom there that we're at etc Wireguard wg0.conf. All right. Now, when we talk about the interface, we are talking about the server. All right. And when we talk about the peer, we're talking about the client. So that means we're talking about the computer that you're on when we're with the client. And then this is, in my case, the laptop. In your case, it could be a laptop or old computer, or it could be a rented Linux box. So the first thing that we want to do is we want to assign an IP address to this server. So what I'm going to do is you can actually set it to whatever you like, but I'm going to say 10.0.0 and then 1. Now we're going to have /24, which means, you know, we can have a bunch of devices on this. I'm going to set the port to 50202. You can choose whatever port you like. It doesn't really matter. You could use the default port if you like, or a randomly generated one. That's just the one that I've chosen. Now, next, the private key that we had from that file, we got to just put that in here. So make sure that you've got the private key assigned. Next, we have transfer unit. So in order to get good speeds, I actually had to reduce this from the default that Wireguard has. The reason is if you've got too much in one packet, right, then could be in a situation where it needs to be fragmented. So for example, Ethernet, it might support 1500, but you know, there is some header information and so forth. And so if it turns out that the total size of the unit being transferred is more than 1500, it'd end up being fragmented, and this can then be to the detriment of your speed. So I've actually set it to 1380, which is a little bit below what Wireguard has by default. Okay, and now we've got these commands, right, for up and down. Now, they're firewall commands, and if you're running Ubuntu, then you're going to need to actually use IP tables. I'll put those commands on the screen. And what we're doing is we're adding this masquerade. Now, why is this important? Well, because the client, or here the interface, it wouldn't be able to route the internet traffic through the server and onwards. It would only work with back and forth communication with your client. So therefore, we've got to add this masquerading. The post down, all that's doing is saying that, okay, during the period wherein this interface is active on the server, during that period, we want to have these rules applied. However, when this service is not active, or when this network interface is pulled down with Wireguard, then we're not going to have it. Okay, so relatively straightforward. Now, what we need to do in this second part, which is the client, is we need to obtain the public key from the client. The time is only just to talk about the Wireguard documentation, which is really awesome. Now, everything that I've been going through so far with respect to the installation and everything, it's all in here, as well as all these commands that I'm going to be doing. The only difference is that I've been setting a conf file, and then we're going to be starting it. But if you want to confirm any of the stuff that we've done here, this is the place to look. Now, what I want you to do is go over to installation, choose the client that you want. So for example, if you're on Android or iOS, you could do that. For myself, I'm going to be working on Mac OS, and I've already got it installed. So go ahead and install it. Okay, and once you've got it installed and it's running, you're going to see it up here. So what I want you to do, we can go to Manage Tunnels, and we're going to create a new one. Okay, and so this one I've called Demo VPN, and the first thing that you see when you open up this new tunnel that you're creating is you're going to see that it's automatically generated you a private key, and there's also an associated public key. So we're going to copy this public key in a moment, and we're going to put that on the server. But before we do this, let's just also set the configuration here on our client. So we've got our address. Of course, that corresponds to the internal IP address on the server, 10.0.0.2, so that this is the address for the peer on the server, and for us it's the interface here on the client. Set the DNS to 1111, and then the maximum transfer unit, it needs to be the same as the setting which is on the server. So I've got it once again at 1380. Under the peer, I've set the public key, so that's a public key that we obtained from the server. Go ahead and paste that in here. I'm allowing all IPs. Now, finally, I've got the endpoint. So this is the one that you either get from your cloud provider on your Linux instance, or the one that we obtained using Telegram bot and our bash script. Put that in here, and then also the port that you're exposing. Once you've set everything up here, you can just save this, and let's head back to the server where we're going to set the public key. So let's just copy this public key and head back to the server. Okay, so we're back here on the server. I'm going to put in that public key that we obtained from our client, and then I'm going to just remove these notes. So we've got everything that we need on this side. We've got this configuration file, everything's declared. There's a few last things that we need to do before we can spin up this WireGuard interface. So write and close, just make sure that you've set the private key that we obtained on the server here. And then we've got the public key of our WireGuard client. Okay, so next what we need to do is we want to set some firewall rules. We've got some temporary post up and post down rules for the masquerading and the routing, all right? But we also need to expose the port. Now I mentioned in that declaration file that I had the port exposed for this WireGuard instance. It was going to be 50202. And so the way that I can add it, and I want to permanently add it because I want this to come up every time, is I'm going to say sudo and then firewall cmd permanent, and I'm going to say add port and 50202, and we're using UDP when it comes to WireGuard. Okay, so it says that it's been successfully added. If you are on Ubuntu, make sure that you take note of the commands that I had just there, because Ubuntu is using IP tables, and on Fedora, the system that I'm using, we're using firewall D. Now what we need to do is we need to enable port forwarding for the server. So the way that we do that, I'm going to run this command. So the command is echo, and then we've got in a string there, net.ip4.ip_forward. We're going to pipe that into sudo t-a and this sysctl.conf. All right, so that's the first command, and we can see that it's been set. We'll confirm this in a moment. Now, the second one is we want to do the same thing, but we just want to go back here. Rather than IPv4, I'm going to say IPv6.conf, and then it's .all.forwarding equals 1. All right, and we're going to pipe that once again into that etc sysctl.conf. Now, the important part now is we need to run this command to actually apply this. So we're going to say sudo sysctl-p. All right, and now we can see that that has been set. We're almost up and running. What we need to do though, one last step, is we just need to start and enable on boot. I'm going to run the command sudo systemctl enable wg quick at wg0. Okay, and run that. It's going to create a symlink. So I'm using systemd on this, which is what Fedora uses by default. Okay, and so we've enabled it to run on boot, but I'm also going to run sudo systemctl start. Okay, and then we can check the status. And we can see that it's active. What I'm going to do is I'm also going to run ipaddr, and we're going to see down here that we have this interface WG0, and it's up at the moment. And we can see that it's set on the correct IP. And so things are looking good on the server side. Now what we need to do is test it. Okay, so our good old friends over at ExpressVPN, they actually have this, what is my IP address location checker. And right now I'm actually running off another network in another location just to demonstrate. So at the moment, here I am in Bangkok, and this is my IP address. So what we're going to do is I'm going to turn on our new demo VPN. So this one here, we're going to hit activate. And immediately we're going to see that data is being sent and received. And if I come back over here and I refresh, you're going to see that the IP has changed and I'm actually in a different part of Thailand. Thank you very much for watching. Don't forget to like and subscribe, and I'll see you in the next one.